Okay guys, I want to try and use my timing light on this thing. What I want to do is I want to spin the motor with the starter and not start it. So you got to be really careful if you're trying to do this, if you're working on your motor and you've got any gas left in the system, in the bowls or wherever. You know, if your motor starts and you don't expect it to start, that can be a real bad thing, obviously. In my case here, as I stated previously, I had absolutely no worries about that happening because my system, all of my carbs have been completely taken apart and cleaned, and the fuel pumps and the lines and everything are all brand new, and it's all bone dry. So I've decided that what I'm going to do for my testing purposes is I'm going to continue to run my ignition system, the electronic ignition system, on my regulated 12-volt power supply because I just feel more comfortable with the voltage quality that I'm getting out of that. I've spoken about this before, but this electronic switch box can be damaged easily and is a very expensive replacement part. Okay, so what I've basically got is two circuits that are going to be isolated from each other. I'm going to have the ignition circuit run off of my 12-volt power supply, and then I'm going to have my start circuit run off of a battery I have here on the ground. So what I've got is I've got my 12-volt main feeder cable coming up to one side of the solenoid. The other side of the solenoid contact goes directly to my starter. The starter, by the nature of the fact that it's it's mounted in the rubber collars, it's isolated from these mounts, so I've got to ground directly to the motor right here. So this is the negative cable going to the battery, okay? And off of this I've got an extra wire. This is the negative wire that's off of the solenoid that's supposed to be going to ground, so I got to go into the starter ground. Off of the starter coil, the 12-volt wire, I have running over to a momentary push button switch. And then coming out of the switch, I'm going over to right here, which is the input side, power input side of the solenoid. This is 12 volts all the time. So I know 12 volts right now is coming up to my switch. When I press the switch, it'll send 12 volts to the solenoid. The solenoid will close the contact, which will send 12 volts out this big red wire to the starter, and it'll spin. So now I have an easy way to hit the starter and get it spinning. Now what I need to do is I need to rehook up my 12-volt circuit to my ignition, and I need to hook up my timing light. Alright, now this is why I hate this this timing light already, even though I just bought it. This spring deal here, the idea is you take the spark plug wire off of the plug, you slide this end of the spring onto the spark plug, and then this end right here is supposed to clip into the boot. But the problem is, if it's not a straight boot, well actually it doesn't really matter. This thing's too short. Now I don't know whether or not that originally was longer and it broke off, or what the deal is. But, as luck would have it, I have one of these steel dowels that's a good fit. Fits nicely in here. Sticks out just enough so I can... Oh, you rotten stinker. That's no good. Let me look at... You know what? I wonder if this is broken. I wonder if this is supposed to be longer originally. I bet you that's what it is. Alright, well, it's not a great solution, but I found the screw that by grinding the head ever so slightly and putting a chamfer on it, I can actually get this screw to kind of plug in. It's not ideal. And then this screw, this end of the screw, I found out will actually thread into here. Threads into the spring. Like so. So if I push this back in there, there we go. Oops. Alright, hopefully that's going to work. Alright, first test. Well, I got the camera here. Let's make sure I got spark. And I do. Okay. All right, next test. Does my timing light work? It does. Okay. All right, I don't know if this fluorescent light overhead's going to give me any trouble. That's working. Now, I could see it working perfectly fine. I don't know whether or not it's going to come out on video when I'm videoing this, because I don't know whether or not there's going to be some kind of weird artifact due to frame rate, stuff like that. So let me see if we can't see this. So hopefully that showed up. All right, so I moved the camera out of the way so I could get my face right in here and make sure that I was seeing what I thought I was seeing, which is I'm seeing that this is at 4 degrees, okay? Now, 4 degrees sounds pretty good based on what I seem to be reading about online in different forums and threads as far as what should be the idle, the timing setting before top dead center for idle on this motor. But what's confounding me is this book. This is an Intertech manual. It was published in 1991. This edition was published in 1991. Now, whether or not any of this stuff was modified to take into account modern unleaded fuels, I think it is, because I'm noticing over here it says open throttle and crank using starter motor, adjust maximum ignition, adjusts advanced screw. So ignition timing is 20 degrees before top dead center. Now remember that this sticker over here on this says 23 degrees, but we know this sticker is for the old way, and we know that if we run it at 23 degrees, we run the risk of melting some pistons. So 20 degrees or 21 seems to be what a lot of people are saying. 21. Some people are even saying 20 to be safe. And I even just read another thread where another guy, another Mercury tech, said, you know what, 19. But what's interesting is in bold print right here, this says, no, due to electronic characteristics of ignition system, maximum advance is set at 20 degrees before top dead center, but ignition will retard to 18 degrees before top dead center at high engine speed. So they're actually making it sound like when you're just cranking it with the starter, you set it to 20, and that's going to equate to, in real world, 18 degrees. So I think on that I'm good with. I think I'm going to go with that. I'm going to go with 20 degrees, just cranking with the starter and max advance. But what's screwing me up here is these listings over here for the idle. The model 900 is 4 to 6 degrees. The model 1150 below, serial number 2928768, is 5 to 7 degrees. But the problem is my serial number begins with a 3. It's actually 327 2624, which I confirmed online is a 1972 motor. And according to this, for some reason, once you go above serial number 2928768 through 3761035, which is the range that my serial number motor falls in, for some reason, it's 2 degrees before top dead center to TDC, top dead center. So what they're saying, top dead center is 0 degrees. So they're saying between 2 and 0 degrees. So according to this book, my 4 degrees I'm getting right now is actually excessive advance. So, you like that? All right, so let's see what max is set at right now. All right, so I've got one of my large cant twist clamps, which opened all the way. It's just large enough so that I can use it to hold this to wide open throttle. So I can see I'm up against my maximum setting here, right up against that. I'm also up against this screw here. So right now, theoretically, if I crank this thing, I should see hopefully no more than 23 degrees advance. Let's see. Oh, I'm in the wrong place. Like, what the heck? What am I looking at? And then I just realized I'm not looking at the right... I was looking at lines on the sticker on here, and I'm using this. So I should be somewhere over here. Here's 20 degrees and here's 25. I'm not even in frame. All right, so here's 20 degrees and there's 25. So I want to be somewhere in here. And right now it looks like I'm at 24 degrees, so that's not good. Wait a minute. Yeah, I'm at 24 degrees. I don't have quite enough height with this camera angle to show that. Oh, okay, that's better. So you guys can see what I'm looking at. Now, that might be 23.5 degrees now that I look at it. Actually see it more clearly on the camera. Maybe I could just use this pointer to point to where I see the line flashing and then stop it and count. Because this is the 25 degree line here. So this is 24. Yeah, so I might be misreading this because it's not that easy to see. I don't have enough hands to move this pointer, hold the timing light, and do all this at once. Alright, bummer. Let's see. If I get the timing light in there just right. That ain't working. Oh, hold the phone. You know, I just read this before. Open throttle and crank engine using starter motor. Adjust maximum ignition advance, screw A, so ignition timing is 20 degrees before top dead center. Note, due to electronic, blah, 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 18 degrees. I skipped over to this and saw this. I totally disregarded the fact that I had inadvertently gone into the next section, which is for models 90, 115, and 140. I do not have a model 115, I have a model 1150. So I'm back in this section here where they actually, to check maximum spark advance, start engine and advance speed control until distributor touches spark advance stop screw. Timing light should indicate full spark advance at 21 degrees before top dead center. So I'm supposed to be doing this with the engine running, and I'm supposed to be doing it at 21 degrees. And I think based on what I've seen online, I'm going to shoot for 20 degrees. And what I just appear to have seen is like 23 or 24. I just did and I already forgot. Okay, so I also now have a little bit more understanding of what they're talking about with this maximum advance. In the book there, it's talking about it also. It's talking about advancing the throttle until it hits a certain stop here, okay? And that at that point, we should already be at max advance, and that's not wide open throttle, okay? Wide open throttle is past that point. And I think that has to do with the fact that on this motor, what's supposed to happen is when you're at idle and you start to push that throttle up towards wide open, that this motor is supposed to be at max spark advance before the butterflies on the carburetor open all the way up. So in advance of the event of the butterflies going wide open, you got to get that ignition timing is already going to be retarding to the max advance. Does that make sense? Did I say retarding to the max advance? Nah. We want to be at max advance before we get to full throttle. If you don't, you will get a bog. So the classic symptom apparently on this motor is this motor is supposed to be able to do what they call a hole shot, which is from an idle, you're supposed to be able to push that throttle all the way up fast, and this thing's supposed to just hit it. I mean, this thing is supposed to be a heck of a motor. If you have a problem where from an idle to that full open throttle event, if it bogs on you, that's a classic indication of improperly set max advance. That you're not getting to your max spark advance prior to the butterflies opening all the way. So keep that in mind. I mean, there are other reasons why that could happen, obviously, but that's something. If everything else seems okay, and that's your only problem, you're going to go back and check that. So there's basically what ends up happening is there's spark advances over here. So I got to take this thing off and do this again. Okay, so this screw right here, this adjustment screw is marked spark advance. And what this screw does is when you, right now the throttle's in the idle position. And when I advance the throttle, what's happening is this upper part of the distributor and the lower part of the distributor are turning in unison. And on the back side is the cam that actually is going to actuate the butterflies on the carburetor. Okay, so what ends up happening is, as I start to turn this, okay, it starts to crack those throttle butterflies open, and you're going to see there's going to be a point where, as the throttle butterflies are opening and this is turning, okay, there's going to be a point where this part of the distributor will stop moving. And then as I continue to pull if I were to continue to pull the throttle, this part would continue to move. Okay, so what ends up happening is, when I get to this point right there, that's where this upper part has a boss that's touching this screw and stopping this from moving. Now if I keep going with the throttle and increasing the throttle, you'll notice this will no longer be able to move. This will. All right, yeah, so I'm sorry, I got that wrong. What I mean is this is what's being stopped. Okay? So now if I advance it past that point, you'll see that the throttle butterflies will continue to open, but this is no longer allowed to move. So that's the point. Right there's the point where it's supposed to be at max advance already. So if I come back to here and I do it again, right there. Seems to be right there. Yeah, that's it right there. Okay, so right at that position there, this is where I want to see the thing at 21 degrees. All right, it's jumping around a little bit, but I think that's 23.5 degrees. So that's not good. Yeah, so 23 degrees or 23.5 degrees, that's a piston melting good time. So let's let's loosen this lock nut. All right, so let's go half a turn out and see what happens. That didn't seem to change anything. Another half turn, that's a full turn, and I've got a, oop. All right, let's see, right there. That's a 25 degrees, so I'm going in the wrong direction. So I'm gonna have to loosen that nut a little more. All right, so let's see, it's a half. That's a full turn. That should be about where I started. Go a half a turn in there. And I think every time I do this, I think I need to, I may be mistaken, but I think I need to come back to closed throttle or idle position and then come back again. That's it right there. That's definitely better. That's 22 degrees. Because I'm going in, I don't think I have to reset. Because screwing in should be moving that distributor. That's 21. If I had an assistant here to press that button, I could literally do this on the fly. That's okay though. Try that. That looks like 20 degrees to me. You know, the problem is when I get in really close for this shot, I can't get the timing light in there. You just see the line there at 20 degrees. And my battery's dying. Okay, what I just did is I tightened the locking nut down and I went back to idle position and advanced until I'm up against the stop, and I'm going to do one final check. That's just about 20 degrees dead on. I'm going to leave it there. And just for the heck of it, let's back to idle position. Let's see where this is at right now. That might be at 2 degrees right now. Huh. That's interesting.